Alright, class, promised you this. This is going to be just going over the proof on the back of our previous page. As I told you in class, basically every single reason you're going to need here, you've seen either listed here or here so far. There's only two spots where it's not one of these ideas, and we'll see those, and it'll be pretty quick and easy. Starting off with, how do we start off with every proof? K is the midpoint of Gj, H is the midpoint of Gi. Why do we know those things? They're given to us. Alright, Gk is congruent to Kj, and Gh is congruent to Hi. How do we know that those line segments visually are congruent? Well, K is the midpoint of Gj, K is the midpoint of Gj, so that seems a reasonable thing. We would normally say that the sides are equal. But since they're saying they're congruent, that's giving us a better hint of what to think about. It's our midpoint theorem. If a point is the midpoint of a line segment, then the line segments on either side are congruent. That's our midpoint theorem. How do we go from being congruent to being equal? Take a minute, look at your list of properties here. Which of our properties ideas talks about being congruent and equal? Congruent and equal, that's the definition of congruence. We'll use a little bit of shorthand. We'll say DEF for definition of congruence. Now we're saying Gj is congruent to Gi. G to J, the entire line segment length, I'm going to highlight that in yellow, is congruent to the entire line segment here, H to I. Well, I don't have Gj up here, I don't have Gi up here. That's another given statement for us. Not all of your given statements are at the beginning. Some of them are later. Now, we know they're congruent, so they must be equal. Definition of congruence again. We know Gj is equal to Gk plus Kj. Let's take a look. G to J, this line segment from G to J is supposed to be equal to Gk and Kj. Well, yeah, that makes sense. Those line segments add up. Oh, yeah, hold on, that's the key there. The line segments are adding, so we're talking about segment addition. We could write the word postulate. Postulate's not super important to writing this word right now, but we're writing it. Now we've got Gk plus Kj is equal to Gh plus Hi. Just pointing out, we just saw those statements. Gh and Hi is here. Gk and Kj is there. Why do we have those equal? Well, because Gj and Gi were equal, and we said Gj was the same as this, Gi was the same as that. All we've done is a substitution. All right. So currently we have the entire yellow hand side is entirely equal to this yellow as well. And we've got GK plus KJ is the same as GH plus HI. But we also said GK was the same as KJ. These two segments are the same. So KJ doesn't have to stay there. It can be replaced by GK as well. KJ was replaced by GK because of this equation up here. HI was replaced by GH because of this equation up here. We have a second substitution. It comes in handy. You use it a lot. GK plus GK. That is 2GK. That's 2 GKs. That makes sense. 2GK. GH plus GH. That's 2 GHs. Yeah, that makes sense. We could say substitution here. We could also say adding. I'm going to write down a list of things we could say. We could say adding like terms. You could say substitution again. You could say simplifying if you want as well. To go from line 8 to line 9, we added like terms, or we substituted, or we simplified. Those were all possible things we could have said. 2GK equals 2GH. Now we're saying GK equals GH. 2 GKs, now we got 1 GK. We had 2 GHs, now we got 1 GH. How do we go from having 2 of something to 1 without seeing any addition or subtraction? How do we get rid of 2 on both sides at the same time? How do we get rid of this multiplication by 2 on both sides at the same time? How do we get rid of multiplication? Division. And we said on both sides. Oh, that's a algebraic property. We're going to use division, property of equality. I'm going to abbreviate this as to prop of equality, EQU. The book simply says divide by 2. You could also have said divide by 2. The last thing we need to see is GK is equal to GH. Now we need GK to be congruent to GH. You've seen this idea 2 times now. We had things that were congruent are equal, but we get to go the other way. Things that are equal are congruent. We got our definition of congruence one last time. That was our proof for this example. Quick note on the test review. I'm not going to do the work. You should try out the test review, but I will make sure you know what the answers were. In class, we were able to say, you were asked to determine if the conjecture was true or false. If the area of a rectangle is 20 square meters, then the length is 10 and the width is 2. We said that was false. The length could be 20. And width could be 1. The length could have been 4, and the width could have been 5. We could have said a lot of different things. We've came up with a counterexample here, where we have things that can multiply to make 20, but they're not 10 and 2. that would make the same area. We also have this question. Given that BCA is 7x plus 1, and given that the measure of ECD was 8x minus 6, and that BCA was congruent to ECD, we wanted to know the angle in between. Well, we know these are equal. So we set them equal. If things are congruent, they are equal. We get to say 7x plus 1 equals 8x minus 6. We solved this. We just got 7 equals x, or using your symmetric property, remember your symmetric property, we get to turn the statement around, x equals 7. Since x equals 7, we were able to find our two angles here. We would have had 7 times 7 plus 1 is 50 degrees, and 50 degrees over here. Now, since we just want that missing angle, we'll call it ECA, actually. We know that the measure of angle BCA plus the measure of angle ECA plus the measure of angle ECD should equal 180 because we've got a straight line. If you know BCA is 50 and ECD is 50, we're left with the measure of ECA plus 50 equals 180. Or the measure of angle ECA plus 100 equals 180. Or the measure of ECA is just 80 degrees. You want to make sure you know how to do these. These are the style questions. These are the sort of things you want to know for your test and for the EOC.